wind our session, let's learn more about matter. Physical substance in general, that which occupies space and possesses rest mass, especially as distant from energy. All physical matter has mass, weight, volume, and density. Matter also has certain characteristics restricted only to specific physical states. Physical matter is made up of atoms, minuscule particles that form physical structures via their electrically charged attraction to one another. Atoms by themselves possesses weight, mass, volume, and density. All atoms constantly move. The more energy that is applied to a group of atoms, the more they move. Atoms in a less energetic state do not move very much at all. They stay in place and vibrate. Atoms in such a state form solid matter. Solids have a fixed mass, weight, volume, and density. Mass is the amount of matter in an object, while weight is the pull of gravity on the mass of that object. Volume is the amount of space the object takes up, while density is a description of how the mass takes up that space. Objects with high density have a lot of mass in a small amount of space. Atoms that are more energetic and hence move more freely are in a liquid state. Liquids also have a fixed mass, weight, volume, and density. Particles in a liquid can flow past one another rather than being stuck in a single position. While solids do not change shape easily, liquids can conform instantly to the shape of their container. Atoms in an even more energetic state form gases. Gases can change not only their shape but also their volume because the particles have enough energy to widely separate from one another while flowing. The kinetic theory of matter states that matter is composed of a large number of small particles, individual atoms or molecules, that are in constant motion. This theory is also called the kinetic molecular theory of matter and the kinetic theory of gases. By making some simple assumptions, such as the idea that matter is made of widely spaced particles in constant motion, the theory helps to explain the behavior of matter. The first assumption in this theory is that the matter consists of a large number of very small particles, either individual atoms or molecules. All matter is made up of tiny particles called atoms or atoms that are joined to form molecules. The next assumption concerns the separation of the particles. In a gas, the separation between particles is very large compared to their size, such that there are no attractive or repulsive forces between the molecules. In a liquid, the particles are still far apart, but now they are close enough that attractive forces confine the material to the shape of its container. In a solid, the particles are so close that the forces of attraction confine the material to a specific shape. Another assumption is that each particle is in constant motion. In gases, the movement of the particles is assumed to be random and free. In liquids, the movement is somewhat constrained by the volume of the liquid. In solids, the motion of the particles is severely constrained to a small area in order for the solid to maintain its shape. The velocity of each particle determines its kinetic energy. There is an exchange or transfer of energy between particles, both atoms and molecules, during a collision between them. The kinetic theory of matter states that matter is composed of a large number of small particles that are in constant motion. It also assumes that particles are small and widely separated. They collide and exchange energy. The theory helps explain the flow or transfer of heat and the relationship between pressure, temperature, and volume properties of gases. Intermolecular forces are forces of attraction or repulsion which act between neighboring particles. They are weak compared to the intramolecular forces, the forces which keep a molecule together. For example, the covalent bond, involving the sharing of electron pairs between atoms, is much stronger than the forces present between the neighboring molecules. Attractive intermolecular forces are considered by the following types: ion induced dipole forces, ion dipole forces, or van der Waals forces.